So now what we're going to do is we're going to keep working on this. We're going to do something in the loop, we're going to do something before and something after, and we're going to accomplish different things. So the first thing that we're going to accomplish is counting something, right? Counting the number of things that we are going to be looping through. Now in this case it's kind of silly, but just in general these are called counters. And so let's just say that we had, dot, 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 a whole bunch of these things, and we didn't exactly, we can look at this and say there are 6 of them, but that's not the point. The point is, if we have a loop, and in the loop we want to keep track of how many we've seen, well, you do this counting thing, okay? So the way it works is, you set a variable to 0, this is the top part. Normally this would be called count, but I'm going to use a bad non-mnemonic variable called zork, just so you don't get too used to it. So we so far, how many have we seen? Well, we've seen 0. And then we're going to go, thing is going to be 9, 41, 12. So thing is going to be the iteration variable. Each time through the loop, we're going to add 1 to zork. Increment is another word for this. Zork equals zork plus 1. We print out the thing we're looking at, and we print out the current value for zork. So the first time through 9, and then that's the first thing we saw. 41, the second. So, and each time this goes up by 1. It doesn't really matter what these things are, but then we run this many times, and when we're done, and we say, okay, loop is all done, right? There's the end of the block, and when it's all said and done, there were 6 things. Now again, 6 is kind of obvious. We could just look at it and know that there are 6, but this is a way to keep track of the number of times that a loop is executed. You set it to 0 at the place, you add 1 to it, and then you print it out at the end. At the beginning, before it starts, set it to 0, add 1 each time through, and then print out the count at the end. So that's counting. The next thing we're going to do is total up a series of values. So in this case, we're going to total them up. Makes a little more sense now. And we're going to have another variable, zork. I would probably call this total. During the loop, it'll be the running total, and at the end of the loop, it will be the total. And so total equals 0. Before, that's the running total of what we've seen. So now 9 comes out, and 0 plus 9 is 9. So the running total is 9, and 9 was what we looked at. Then 41 comes in, then we take 9 plus 41, the running total is 50, we read 41, go back up, 12 comes in, 50 plus 12 is 62, so that's our running total. Next time we get 3, 62 plus 3 is 65, so this line prints out. Then we get 74, so 65 plus 74, 65 plus 74 is 139, so that's the running total. We go and do the last one, 15. 139 plus 15 is 154. We print that out, and now it goes back up, but the for loop is done, so out we come. So at the end, when it's all said and done, this running total becomes the total, 154. So we know certainly when you print all this stuff out, right, you wouldn't print that out. But at the end, if you do this, and so the difference between the count and the total is instead of adding 1 here, you add the thing you're running that you're totaling up. So that's how we compute totals. And of course, we can do this with an average, right? So now we're going to have a counter, which we set to 0, a running total, which we set to 0 in the variable sum. We're going to print out 0, 0, so the count and the total is 0. We run through. Each time through, we add 1. So it's going to be 1, 2, 3, 4, 5, 6 each time through. Then we have the sum equals sum plus value, so 9, 50, 62, 65, 139, 54. So this is the running total. This is the count. Actually, that's the sum in this case, the sum variable. And then this is the thing that we were reading in. And then we finally get done, because there was only 6 things. The for loop dumps us out. And then we got, oh, okay, how many did we get? We got 6. What was the total? It was 154. And then divide sum by count, and that should be 25.0. Okay, and so we divide sum by count, and now we have calculated the average. Actually, this should be 154 divided by 6. I think that should be 25.6666 or something like that. Okay, so you get the idea. And so you sum, and so you can do more than one of these things in a particular loop. Now, filtering is the idea that we're looking for something that meets some criterion. So we're going to go through and look at all the things in the loop, and we're trying to figure out if something is greater than 20, and we're going to declare that large number. So this is how you put an if in the loop. And so sometimes this loop will do nothing. Sometimes this loop will print out large number. And so value is going to be 9, and that's false, so it doesn't do anything. Value is 41, that's true, so it prints out this. Value is 12, so it does nothing. Value is 3, it does nothing. Value is 74, and so it prints this out. Value is 15, so that's false. It's done. Now the for loop knows, oh, we're done. Go on to the next line. Okay, so this is kind of a filtering pattern where, we're going to do some if statement and conditionally run some code based on the value that we're looking at for now. So that's like searching for large numbers in our long list of numbers. Sometimes instead of printing something out in the middle of the loop, just like in functions, we don't often print in functions. We tend to prefer using return values. Sometimes we just want a variable that tells us whether something was found or not. And so we're going to use a Boolean variable. And so a Boolean is another type of a variable. You got integer variables, you got string variables, you got floating point variables. Boolean is another kind of variable. Boolean is a kind of variable that it either has the value true or false. That's it. It can only have two. And so false is a constant in Python. And so I'm going to say found. Found is a mnemonic variable. I use the word found for this all the time, but don't get stuck on it. It just happens to be a variable with the value false. So we print it out before it's false. And now we're going to go through each of these values again. And we're looking for 3. And we want to know, did we find 3 or not? So we have 9, and it stays false. We have 41, it stays false. We have 12, it stays false. Now we have 3. This all of a sudden clicks to true. And so then we change the variable found, which is the same found here, to be true. So this time when we come up through 3, we run this code, then we print this, and it's true. Now it's 74, this is false, but we've changed the variable for found, so it doesn't change back to false. So we run the rest of the loop, and when we're done, true. And so at some level, if you didn't print all this stuff out, before, after, that means we found a 3. There could be a million times that we ran this. And all we know when we're done is there was a 3 in there. So that's what's saying. Found starts out false, it loops and loops and loops and loops, and if it ever finds it, then found becomes true, and then we can detect at the bottom of the loop, yes, we found it. Yes, that happened. No matter how many numbers we looked at, one of them, at one point, at least one of them, was a 3. Now, if we were a little tricky, we would realize that we could put a break right here. Right there. Because once it's true, it's not going to go back to false, so we could stop. So we've done a bunch of different things, right? We found the largest, we searched for value, we did some sums, we did some averages, and now we're going to do the smallest value. And so just before we do the smallest value, let's review what we did for the largest value. Okay, and so we have this variable called largest so far that we set to -1, and then we print it out. It starts being -1. And then we're going to go through this loop, 9, and the largest so far is 9, and then we go 41, we like that one better, and then we like 12, we don't like that, we like 3, we don't like that, 74, we keep that, and then 15 doesn't make any difference, and then it pops out, and we get 74. That is the largest, not the largest so far, but the largest you would get. So the question is, what would we do to change this to make it search for the smallest value in the list? Now you can look. Humans are good at this. Like, hey, what's the smallest value? It's 3. Yeah, of course, you know that. No, we got to think like a computer. How are we going to find the smallest value in the list? What would we change here? What are some of the things you might change? Well, there's at least a couple things you would change, right? So the first thing you would do is let's just change this from a greater than sign to a less than sign. And let's just change the word large to small. Is that going to fix it? Take a second. If I changed all the word largest to the word smallest, and I changed the greater than to a less than, is that going to fix it? If I did that, what number is going to come out here? Is it going to be 3? that going to come out? So, like, if I did this, is that going to make it better? Is it going to print 3? Obviously, if I'm staring at you, probably it's not going to. This was a trick question, right? It was a trick question. This is what happens when you run it. So, we start out, smallest so far is -1. We come in with 9. Is 9 less than -1? No, it is not. So we skip. So the smallest we've seen so far is -1. We go back up. Is 41 less than -1? No, it is not. So we skip. So the smallest so far is -1. 12? No. 3 is not smaller than -1. 74 is not smaller than -1. 15 is not smaller than -1. So out we come, and the smallest we've seen so far is -1. No, it is not. So what's the flaw in our logic here? First off, the word smallest so far doesn't mean anything. This could be gorp or zap or x. So just changing the variable to say smallest so far is highly misleading. Okay? So at this point right at the screen to the one place that has the fallacy, the mistake in this code. If you pointed right here, you're correct, right? So baked into that, when we were doing largest so far, was that these were positive numbers. And smallest so far, you know, starting -1, if they're positive numbers, well, smallest so far is already smallest than the smallest possible number. So what number might we put there to make this work better? Well, some of you might suggest that we would just say, oh, that'll be okay. I'll make that be 100, and it's going to work fine, right? And so 9 will tick, 41 will ignore, 12 will not work, 3 will tick, and it'll work. It'll work. That's fine. That would work if you made it 100. But then, what if there was 3-digit numbers in here? How would that work? Well, like, oh, let's make it 1,000. Yeah, that's it. No, let's make it 1,000,000. Or like more, right? What's a big enough number? As a matter of fact, largest so far code that we did, if there were negative numbers and they're all negative, this is not going to work so well. Wait, largest so far. Yeah. This is just not going to work very well, because what if they're all negative numbers? We just assumed they were positive numbers, and it worked just fine, didn't it? Whoops. Okay. So there's kind of a flaw. We were using this -1. There's a word for it. It's kind of like a flag value. It's not really the smallest number we've seen. It's like an indicator that we haven't seen any numbers. And we can't really pick a number for this. Frankly, either in the largest or the smallest. It's just not going to work. And so what are we going to do? Okay, so this is what we do. We have yet another type of variable. Remember I had Boolean, true and false, integer, floating point. There's a variable called none type. None. And it only has one constant in it. So Booleans have true and false, integers have a whole bunch, and then floats have a whole bunch, and none types have one thing, none. We think of it as the absence of a value, the lack of a value, okay? And so what we're going to do instead is in our smallest variable that we're going to do, we're going to say, you know what? Before this loop starts, the smallest number we've seen is nothing. We've seen no numbers whatsoever, and that's going to be our marker to indicate that we've seen no numbers, okay? This is kind of like the found code, where we set found to be false, and then later we set found to be true. But we're going to use smallest equals none. None is a variable, a value that we can distinctly detect different than numbers, okay? So we can say, is the contents of smallest none? If smallest is none. Is like, it's more powerful than double equal sign. It means, is it exactly the same as? And so if we are asking, is smallest none, that's only true if we've got a none in there. If we put 17 in smallest is not none. So this is how it works. You start with smallest equals none, and then in the code we have a little bit more intelligence. If smallest is none, this means that it's the first time. If the smallest is none, smallest is value. So 9 is coming in here. And so if the smallest that we've seen so far is empty, we have seen nothing, then we'll grab the first one as the smallest one. So our 9 becomes the smallest one. And so that's how we print out the smallest so far is 9. We just saw 9. Then we come up. The second time through this loop, this is going to always be false from now on, because smallest is a number, and number is not none. Okay, so we have this flag value that's none just for the first time through the loop. So that's false, so it's going to run here. Elif value is less than the smallest, which is 41. Is 41 less than 9 in this case? And the answer is no, it is not. So it stays 9. Then 12. 3 works, so 3 causes this code to run, so we grab it. So 3 is it. Then we go through 74 and 15. It runs 2 more times. And then when we're all done, we get 3. This is a flag value that we're checking. And through the loop, it'll only be smallest will only be none the first time through the loop. But after that, we'll just ignore this little part. This is another way to think about this is priming us. This is getting started. Okay, and this technique is a good way to do the largest and the smallest, to use this none, and then have a little bit of code that triggers the first time through the loop to get your sort of loop carried variable set up. Okay, so the is and is not operator, they're both operators. They're like is and is not are like less than or equal to or not equal to. They don't hurt their operands, and they return you a true or a false. Okay, so is none and is not is also a logical operator. And there are other times we use it. You shouldn't use is when you should be using double equals. Usually you're using them for true, false, or none. So that we don't overuse is, because is a really, really strong equality. So it's a stronger equality than double equals to. So the double equals is mathematically equal to with potential conversion. But is a stronger thing. And is not is the opposite of is. Okay, so in this chapter we've talked about some definite loops, some indefinite loops, break to get out of loops, continue to pop back up. Continue works in for loops as well as while loops. Iteration variables, how with while loops you construct them yourself, and in for loops for constructs them for you, and things like largest, smallest, counting, average, etc., etc., etc. So we looked at some loop idioms where you do something at the beginning, do something in the middle, and then you get the payoff at the end.